In this video, we're going to have a look at how to calculate two-step probability questions using tree diagrams. Now, two-step probability questions involve two events happening. So for example, you could roll a die twice, you could flip a coin twice, or you could roll a die and then flip a coin. Each of those are examples of two-step chance probabilities. So you can calculate the probability of an outcome involving both events when you do two-step chance probability calculations. And one way of completing those calculations is drawing a tree diagram, which helps you to determine the possible outcomes and then assign probabilities to those outcomes. So let's have a look at an example. In this example, two dice are rolled together and the number that appears on the top is noted. In this experiment, we're looking at the probability of getting fives. So we want to prepare a tree diagram and answer the following. How many outcomes contain at least one five? And then what is the probability of getting a five? So the first step is going to prepare a tree diagram. Now there's a couple of different options around preparing this tree diagram. The first is we could prepare a diagram that has 1, 2, 3, 4, 5, 6, and then another series of 6 for each of those. That tree diagram is going to end up to be very large and very complex. Because we know in the question that we are looking at the probability of getting a 5, we can look at doing a reduced tree diagram. So instead of looking at all the possible outcomes, we can look at the possibility of getting a 5. So when I roll the dice the first time, I have a probability of receiving a 5 or not receiving a 5. That's on my first roll. And then on my second roll, again, I've got a probability of receiving a 5 or not a 5. So that is a much more manageable tree diagram to then go ahead and answer my questions. So on my first roll, I have one outcome of getting a 5 or 5 outcomes. That's going to get me not a 5. On my second roll, it's going to be the same. I'm going to have one outcome that gets me a 5 and 5 outcomes that get me not a 5. So how many outcomes contain at least one 5? So having a look, I got 4 possible outcomes in my tree diagram. So the first outcome is receiving a 5 and a 5. The second outcome is a 5 and not a 5. The third outcome is not a 5 and a 5. And then the last outcome is not a 5 followed by not a 5. So only one of those possible outcomes give me a result where I'm not getting at least one 5. So now I want to go ahead and assign probabilities to each of those outcomes. So in the first roll, the probability of getting a 5 is 1 over 6, because there's one outcome that's going to give me a 5 out of 6 possible outcomes. And the probability of not getting a 5 is 5 over 6, because there are 5 possible outcomes that are going to give me not a 5 out of a total of 6 possible. And I can go ahead and assign that probability for this second roll as well, because my probabilities are going to be the same. So now I want to work out the probability of each of those occurring, and I do that by multiplying the probability from the first and the second step. So the probability of getting a 5 and a 5 is going to be 1 over 6 times 1 over 6, which is equal to 1 over 36, because I multiply my numerator and my denominator. For 5 and not a 5, it's going to be 1 over 6 times by 5 over 6, which is going to equal to 5 out of 36. Probability of not a 5 and a 5 is going to be 5 over 6 times 1 over 6, which is equal to 5 over 36. And not a 5 and not a 5 is going to be 5 over 6 times 5 over 6, which equals to 25 over 36. So now I've assigned a probability to all of my possible outcomes. To answer part B, the probability of getting at least 1 5, that is going to be 1 5 contained in the first outcome, at least 1 5 contained in the second, and 1 5 contained in the third. So the probability of at least 1 5, I need to add all of my successful probabilities together. So probability at least 1 5 is going to be equal to 1 over 36 plus 5 over 36 plus 5 over 36, which is equal to 11 over 36. So the probability of it getting at least 1 5 when I roll 2 dice is 11 over 36.